Hello everyone, this is Archana from 4th year CSE AML, and now I am excited to present you all about our group project, that is yoga pose optimization using deep learning techniques. Now let's explore the abstract of the project. In the digital age, as more yoga practitioners turn to online platforms for instructions, a notable gap has emerged in receiving real time feedback on yoga poses. Despite the wealth of resources available, such as instructional videos and written guides, learners often struggle to ensure they are executing poses correctly without direct guidelines. This lack of immediate feedback can lead to improper posture, potentially causing long term health issues. This next section focuses on motivation and background. New yoga practitioners can't tell if their pose is correct or not without a teacher's help. So, we suggest using a computer program to check yoga poses and give feedback. This program uses special technology called deep learning to recognize poses and alert practitioners if they need to make any adjustments.
This is Nitya from 4th year CSE AML. Here is the objective of the project. A new solution has been found to help with yoga poses using artificial intelligence to optimize yoga postures. The YPN MSSD model is a leading solution that combines two powerful tools, PoseNet and MobileNet SSD. PoseNet helps identify important body points like joints and limbs. MobileNet SSD detects humans in each frame like a video. Together, they help recognize yoga poses accurately, making it easier for people to practice yoga correctly and safely. Coming to the introduction of the project, technology and science have changed our lives for the better. One of the most significant impacts has been in the healthcare sector, where technology has transformed medical diagnosis, treatment, and patient care. Additionally, the recognition of alternative practices like yoga, Zumba, martial arts, and other physical activities as essential components of overall well being has gained popularity. These practices are now acknowledged as vital elements of a holistic approach to health, complementing traditional medicine.
This is Ravalika from 4th year CSE AIML. Now I am presenting the literature review for my research on yoga pose optimization detection. So, recent studies have explored using advanced deep learning and machine learning models to improve real-time yoga pose recognition and feedback. Researchers tested various deep learning models including CNN LSTM and 3D CNN models to achieve high accuracy and fast processing. After optimization, the best model ran on a lower power device at 8 frames per second, making it feasible for self-guided yoga practice. Another study used CNNs and YOLO for pose detection, with YOLO showing superior accuracy compared to other models and bridging traditional yoga and modern technology to enhance the personal practice. A proposed system combines deep learning with multimodal data to provide real-time accurate feedback, useful in multiple settings and potentially benefiting from future integration. Other studies developed simpler application for real-time feedback, such as an app using KNN classifier trained on web scraped data, achieving 83.6% accuracy and offering voice feedback for safer practice. A model for pose alignment feedback aims at injury prevention, while another focuses on personalized feedback for breathing and focus, using a hybrid model with an accuracy of 90.9%. These studies collectively advance yoga practice with technology, enhancing accessibility, effectiveness, and safety. And here comes existing system. Learning yoga in presence of the trainer is already existing. Learning through uploaded videos in the social media platforms and virtual yoga studios.
This is Nikita from 4th year CSE AML. Disadvantages of existing system. Many yoga instructors teach online, however, students can't get live feedback on their poses, which can lead to poor posture and health issues. Lack of discussion forums or social features. Poor video streaming quality. lack of real time feedback from instructors, lack of safety guidelines and precautions, inadequate modifications or adjustments for injuries, problem identification, lack of real time feedback and guidance in online yoga classes about proper pose execution, posing health risk for beginners, inability to receive immediate feedback on pose alignment and execution, limited visibility and correction of poor posture and movement patterns, increased risk of injury, difficulty for beginners to self correct and improve their practice. These are the problems we identified. Thank you. Now Ravilka will continue.
Let's move on to the proposed methodology. The model is structured into three primary stages: data collection and preparation stage, feature extraction stage, and posture recognition stage. Initially, data collection and preparation involves capturing yoga postures from multiple users, supplemented by an open source dataset featuring various yoga poses. Once the data is collected, the feature extraction process begins, and this is the second stage, where an PoseNet is employed to identify key anatomical landmarks and establish the spatial relationships between them. This diverse dataset forms the basis for training the model, during which feature extraction occurs by connecting key points on the human body. And this is the last stage. Building upon the extracted features, the model utilizes the MobileNet SSD layer to perform real-time posture recognition. Through this process, the model learns to recognize yoga postures in real time, providing users with live tracking capabilities and immediate feedback on their form. Now I'll hand over to Archana to explore the next topic.
Now we will delve into the topic called architecture of proposed methodology. Here the picture shows the entire architecture of the project. The first step of the proposed methodology is the collection of image dataset, and then in the next step it is converted into numerical data, and in the next step it is trained using YPN MSSD model. The next step is to provide real-time user input, and which is tested in the next step using YPN MSSD model. And coming to the further step, feature point detection for each frame will be happened, which leads to the conclusion, that is recognize correct or incorrect pose. Let us proceed into the topic, which is implementation and results. We collected the image dataset from the Kaggle, and then it is converted to numerical dataset for further execution, as I mentioned in the previous slide. We pre-processed the data using deep learning techniques, and then the data which is divided into training is trained using the proposed model, which is YPN MSSD. After doing all this, we combine the train results with React to implement an interface. Here comes the interface implementation. When we access the interface, it asks us to allow camera to access the capture pose. And second step is to select the pose. And the next step is the user have to read the instructions to practice the yoga pose to avoid complications. Then user have to click on start pose so that user can see the image of that pose on the right side and can do that pose in front of the camera. If the user performs the correct pose, the skeleton will be in green color, otherwise it shows white color. Now my friend Nitya will take over the next slide.
Here the images provided demonstrate a yoga pose optimization system that uses deep learning to provide real-time feedback on a user's yoga posture. The system analyzes the user's movements through a video feed and overlays a skeleton model to visualize their pose. Green lines on the skeleton indicate correct alignment and posture, while white lines suggest areas where the user needs improvement. This visual feedback helps users identify and correct mistakes in their yoga practice, leading to a more effective and injury-free workout.
This is Nandini from CSCAML. Coming to the conclusion, Proper pose is critical in yoga and technology, particularly deep learning models holds promise in ensuring correct performance. The model leverages PoseNet for future point detection and MobileNet SSD for human detection in each frame, providing a robust combination for accurate posture recognition. Coming to the future scope, in future the yoga pose recognition application can be trained with more number of yoga poses. Additionally, full-fledged training can be performed to build a fully adapted real-time model for a real-time noise environment to act as a professional yoga trainer. An audio based alert can be included as part of the future scope to indicate a signal to the user when the correct pose is attained. Thank you.